Hi everyone, welcome to my new course designed to help you pass your electrical journeyman, master or electrical inspection license on the first try. As you can see on the screen, I obtained my journeyman license in 2021. After 1 year, which is the required period by the state of Virginia, I was eligible to take the master exam. I took and passed my master exam in 2022, just over a year later. Subsequently, I obtained my license in Washington, D.C. and Maryland in 2023, as you can see on the screen. Many students who fail the exam struggle to find answer in the code book despite understanding the question. Throughout this course, I will share the strategies I use to prepare for and pass these exams. My approach involves understanding the logic behind the questions and learning how to navigate the index to find the related article for the questions, and then going back to the code book to find the answer effectively. I promise you that if you follow these steps and approaches, you will have the skills to answer most of the exam questions correctly. After completing the first 25 questions and learning how to read questions, what keywords to look for, and how to find the correct answer easily and accurately, you will feel confident in your preparation and can schedule your exam. I assure you that you can be successful. There are specific techniques and resources that we will cover together. To start, you will need some tools, relevant books, and practice material. None of these resources I recommend I sponsored. I am simply sharing what helped me succeed. First, understanding the requirement for your state exam. This means you need the appropriate code book, whether it's 2017, 2020, or 2023 edition. Matching your study material to the year of your exam is crucial. I recommend the Ray Holder exam prep books. Whether you are preparing for the journeyman or master exam, these books provide excellent practice questions. The questions are standard, which means you can answer within 3 minutes. Additionally, Tom Henry's index book is a must-have. It helps you quickly find answer, acting almost like a cheat sheet. This book can help you to save a lot of time finding the answers compared to NEC index. The NEC index section also necessary to find some specific question. As you see in the screen, you need Tom Henry's keyword index, not handbook edition. You cannot carry handbook to your exam. Also, for those preparing themselves for master exam, I highly recommend Tom Henry's calculation book. Please match the calculation book with your code book. That means if you have 2017, take the 2017 calculation book. If you have 2020, do the same. Tom Henry's calculation explain complex concepts in simple language and help me answer nearly all the calculation questions on my exam. And finally, I recommended smart tabs. These tabs are not available on Amazon or eBay and are sold directly to customer by the creator. They are much better and more applicable compared to what you see on the market. They are larger and more useful than tiny tabs. I especially like the motor section, which is like a cheat sheet. When we go over the test on motor section, I will show you some areas where these tabs are helpful. You can visit the seller's website to get an idea. After covering these foundation topics, we will move on the practice test. I've randomly selected questions from Ray Holder's book and some from the electrical inspection exam. By answering these questions, you will gain confidence and see how they mirror real exam questions. I used my 2020 code book and Tom Henry's index for 2020 edition. Let's get started and I will see you in the first set of questions. Question 1. Where multiple driven ground rods are installed, they shall not be spaced less than A 2 feet, B 4 feet, C 6 feet, D 8 feet apart. For this question, let's focus what is the main keyword which help us when we go to the index find our answer, find the area we're looking for our answer, find the article related to the main keyword. I believe ground rod is the keyword, and everything related to the ground rod is installed, multiple, and space. And if I highlight what is the keyword and related to keyword are here, ground rod, and these are all somehow hooked to keyword. When we talking about a space, we talking about something like the width, depth, height. Let's go to the Tom Henry's index to see where is article related to ground rods. When we go to Tom Henry's index, we see there is a ground rod related keywords here. Looking for some driven depth in soil 8 feet, which is these are close to related words. Then we jump to the 253 grounding electrode system installation. When you find the keyword in the article area, you need to navigate a little up and down, or maybe one page back and forth to find your answer. Here we have a, as we said, installation area. Then let's navigate to A, to supplemented electrode, rod and pipe electrode. Then we come here, it talks about electrode spacing. What we're looking here, when you read through, it says shall not be less than 6 feet from any other electrode of another grounding system. We don't want to waste time. You can go read through, and this is exactly what we're looking for our answer. Then the answer is C, 6 feet. Now let's see how we can find the same answer in the NEC index. When we go to grounding electrode conductor, they say see also electrodes grounding. Let's go to electrodes grounding electrodes, see electrodes grounding. Then we go to the next page, and here we have electrodes grounding. Just remember, when you searching for the keywords, start as a electrode grounding, then A, there is no B, C, D, E, there is no E, F, G, I, M, and S, separated drive, and also system installation 250-53. And this is help us to go to the same area 250-53 and start our navigation around this area to find the answer. See you guys in the next question. Question 2. Where a one family dwelling has a 200 amp 122 volt single phase main service panel and is being supplied with size 2/0 THW copper ungrounded service entrance conductors in rigid metal conduit RMC, the minimum allowable size of the bonding jumper for this service entrance conduit is A, 6 gauge, B, 4 gauge, C, 2 gauge, D, 1/0 copper. Our main keyword here, which is help us to go easily to index and find the answer, is bonding jumper. We're looking for bonding jumper size, and for which area, for service entrance, and we're looking for copper. Now if I highlight what we said, we have bonding jumper for service entrance, which is looking for size, and copper. Let's go to Tom Henry's index to see where we should go. We have 3 options for bonding jumpers, which is bonding jumper size, as we looking in our question, tell us go to page 127, table 250 102 C1. I'm going to the table 250 102C1, which is main bonding jumper, supply side bonding jumper, and this is exactly area I should find the size I'm looking. Now, if I put the information from question one by one to match with this table, I have this area, which is number 1 talks about 2/0 or 3/0. We are looking for 2/0. 2 talks about copper. This side, it says ungrounded service entrance, which is size of largest ungrounded conductor. Then what we're looking for bonding jumper size, which is this part of the table, bonding jumper size. What we looking for copper bonding jumper size or aluminum copper cloud bonding jumper size. We're looking for copper, then we should be here. Then if you go all the way to your right and come the column down, the intersection, give me the number 4 gauge bonding jumper wire size, which is number 4 gauge. The answer is B. Now let's see how should I find this in the code index. If I'm going to the NEC index, it says bonding jumper C jumpers bonding. We are in the B area. Then we should jump to J area. I'm going to J area to see what I should see. J area, jumpers bonding. Then, and when we go all the way down, we have service equipment, which is I should go to this article, this article, this article, which is here. Definitely I find the answer. But the difference is, before I waste my time in this article and this article, I go straight in the first try to the table Tom Henry's gave me, and I find my answer. And if I try to summarize what the question asks us, is Mike Holt's great visual book for code book, which is, they says the supply side bonding jumper is size to table 250 102C1 based on the largest ungrounded conductor within the racer or cable. That means this wire we're looking for size, and the size is 4 gauge wire based on the table we just follow step by step. See you guys in the next question. Question 3. A disconnect switch enclosure installed in a class 2 division 2 location shall be A. dust tight, B. heavy duty type, C. rain tight, D. general duty type. The keyword here, anything related to class, which is we specifically looking for class 2 division 2, and we're looking something related to enclosure. Remember, whenever you're looking for class information, to go to the index in the NEC area. There is no related information for class 1, 2, and 3 location. You should go in the NEC index to hazardous classifier location. Don't waste your time in the class area, which is you are in the C area. Here it talks about C class 1, 2, and 3 circuit, but you should jump from C area to H area, which is, if we follow all the way to H area, you see hazardous classified location. If you're looking in the Tom Henry, you should go to class area. The Tom Henry's book is everything is based on the class. Now if we try to summarize what we're looking for class 2 division 2, and we're looking for enclosure or disconnect switch. Now what we have here, the closest area we should take a look is class 2 division 1, which is generally when we have a class 2 division 1, we have class 2 division 2, and if there is possible class 2 division 3. But if I'm trying to show you what I'm talking about in my code book, you see if you jump to the class area, the class 2 division 1 is here, and opposite side of the page is class 2 division 2. Then let's go to see where we can find the answer in the code book. I'm jumping to 502.10, which is wiring method. Then I'm in the class 2 division 1. I scroll down, class 2 division 2, which is talks about the general, but when we just read fast to see what is talking, we just come to the box and fitting. All boxes and fitting shall be DOS tight. That's the answer. What's the answer is A, DOS tight. Now let's go to NEC to see what we have. If I'm going to hazardous classified location 2, when I just navigate through the closest area I can find, I should go start from the wiring method, because in the wiring method, when it talks about installation of any box or talks about some specific requirement, and that is the area we should start to navigate through. See you guys in the next question. Question 4. The interior of enclosures or raceways installed underground shall be considered to be A, dry, B, damp, C, hazardous, D, wet location. The keyword for this question is something like enclosures or raceway, and we're looking for install underground, and we have something related information for interior. If I summarize, we go to enclosure or raceway and pay attention to install underground, and we're looking for somehow interior. Unfortunately, Tom Henry's index doesn't give me any information, and you can check it out if you have his index book. But let's go to NEC to see what we should looking for. I'm going to first to raceway and then go to find something related to underground. And raceway, just navigate fast down from A, B, C. We're looking for U area, which is fast. You can go E, F, G, or you just come from the bottom to top, L, and we are in the U area. And underground, we start with the article 300.5. If we couldn't find answer, then we jump to 300.50. Let's go to 300.5. 300.5 give me underground installation, minimum cover requirement, B, wet location. The interior of enclosures, this is exactly what we're looking. Or raceways installed underground shall be considered to be a wet location. Then the answer is D, wet location. See you guys in the next question. Question 5. Determine the maximum allowable current carrying capacity of 4 size 1/0 THW copper current carrying conductors installed in a common raceway with an ambient temperature of 86 degrees Fahrenheit. A, 150 amperes, B, 105, C, 112, D, 120. Looking the question like that, which is asking about maximum allowable current carrying capacity of 4 wire or with this temperature and the copper, generally this kind of the question referring us to the ampacity of the wire, the ampacity table, and based on the condition we have, we should follow with some rule. Now remember, the main keyword is maximum allowable current carrying capacity, which is we go to the ampacity table. What we're looking there, definitely we're looking for should be 4 wire, this kind of the wire, which is 1/0 THW and is installed in a raceway, and this is the ambient temperature for the raceway. Now if I to highlight what we so far covered, we go to this page and you see the NEC 2020, the ampacity table 310.16. In NEC 2017, the table is 310.15 B16. Now let's go to see how we can find in either of those index area. If I'm going to Tom Henry's index, navigate through ampacity. There is a lots of ampacity, but what we're looking for something like copper ampacity. And if I'm go through fast here, it's just telling me ampacity, 15-minute motor, adjustment factor, ampacity, aluminum. Some area talks about aluminum. There is a more chance to talk about copper also. Then we highlight this area and we go to table 310.16, page 161. Now see how we can find this in the NEC codebook. In the NEC codebook, if we go to the raceway, as is the question said, install in a raceway, then in the alphabetical is the A, ampacity of conductor, referring us to table 310.16. We go to 310.16 to see what we're really looking for. I tell you step by step what we should do. This is the table 310.16, but I try to show you one time forever to learn about this table and related table. The index told us come to this table. Ampacity of insulated conductor with not more than 3 current carrying conductor. Our question was talking about 4 current carrying conductor. Then this is probably the good start, but let's see what is the next step. In a raceway, which is our question was in a raceway, cable or earth directly buried. Now all of these tables has more information in the header and in the bottom of the table. Let's see what it talks about the next step. Note 1. Section 310.15b shall be referenced for ampacity correction factors where the ambient temperature is other than 3 degrees Celsius, 86 Fahrenheit. What he tried to say in the note 1 in the summary is you can use this table if only you have the temperature of 30 degrees Celsius or 86 Fahrenheit. If it's other than that, you should go to this table 310.15.b. and if you see here, I put side by side this table, which is and put with the arrow temperature greater than 30 degrees Celsius or 86 Fahrenheit. We should go to this table and they give you ambient temperature correction factors based on 30 degrees Celsius. If your wire installed in the other than 30 degree 86 Fahrenheit environment, you go to this area for Fahrenheit, you go here for temperature for Celsius and find related column to make adjustments. And if you see 50 Fahrenheit or less, you come to this area or this one or this one, and these are the correction factor. Now our question said we install in this temperature of ambient temperature of 86 degree Fahrenheit, and then what we have here is good for us. Now let's go to see what the note 2 says. Section 310.15c.1 shall be referenced for more than 3 current carrying conductor. That means if we have more than 3 conductor, whatever we find in this table, we should go to another table, which is this table, and I put it side by side here, and I said more than 3 conductors. Then we should go here and make adjustment factor based on the number of conductors. 4 to 6 conductor, 80% derating factor. 7 to 9 conductor, 70%. And these two is related to what we said here. But one more thing, what about if somebody says in the question is a single conductor and installed in the free air? Then there is another table, which is, I put it here, ampacity of single insulated conductor in free air. Whatever we talked, you should come to this table and do the same thing. For now, let's go back for our question. If put the question here and put as we read, I put the number 1, 2, 3 to each related area to figure out what is the answer and what is the step we should follow. First, it talks about 4 wire. Number 1 is 4 wire. When I'm referring to this one, if you see green one, here is not more than 3 current carrying conductor, then we need to do something because this table is just for 3 wire. Now let's go to the next step, is a 1/0 THW wire. The 1/0 is number 2. I'm looking for this, the wire gauge for 1/0. Then what kind of the wire? Number 3, THW. I find the THW in this column, which is 75 degrees Celsius, 167 Fahrenheit. And then it says THW copper. Then 4, which is 4 here, copper. Remember, this is a copper. This area is copper. This area is aluminum or copper clad aluminum. We don't need anything here. And finally, when we go read the rest, is a 86 degree Fahrenheit, which is, we saw, as you see, 5 here, 5 here, and 5 here. The environment we installed is matched with this table. Now, the only issue we have is we have 4 conductor in the question, but this table is related to 3 conductor. Now, let's see what we can find here. If we follow the copper all the way down and 2/0 all the way to right side, the intersection give me 150 amp. That means in this situation, the 3 wire can carry 150 amp. Now we have 4 wire. That means in the 4 wire in this raceway generate more heat. What is my adjustment factor? Then from here, as we read before, we go to the derating factor, which is section 310.15 C1. If I'm jumping to that table, which is, this is adjustment factor for more than 3 conductor. I have 4, and this is just coverage for 4 to 6 wire, and adjustment factor or derating factor is 80%. Now the 150 from before derating, multiply it to 80% adjustment factor, they give me 120 amp. Then if I back to my question, D is the correct answer. And see you guys in the next question. Question 6. The NEC defines a continuous load to be a load where the maximum current on the circuit is expected to continue for at least A 3, B 4, C 6, D 8 hours or more. Keyword here could be continuous load, and related information to keyword should be maximum current or expected to continue for how long. And if we highlight, we have continuous load, maximum current, and these are related information or keyword. Then if I'm going to the Tom Henry's index, continuous load branch circuit, continuous load feeders, continuous load service, which is really doesn't help me. If we don't see anything here, fast we jump to the NEC code to see what we have in the index area. If I'm going to the index area, in the continuous load, if I'm just go alphabetical to the down to see definition, probably because they ask us to what is continuous load, we need to something to define what is that means. Let's go with the article 100, see what we have. If we go to article 100 to the C section, C, which is CO, conduit, CON, okay, continuous load. A load where the maximum current is expected to continue for 3 hours or more. Then the answer is 3 hours or more. A is correct. See you guys in the next question. Question 7. Determine the minimum size THW copper branch circuit conductors the NEC requires to supply a 3-phase continuous duty AC motor that draws 70 amps per phase. Consider all terminations are rated for 75 degrees Celsius. A 1 gauge, B 2 gauge, C 3 gauge, 4 gauge. The keyword here is branch circuit, but branch circuit under the motors area, because the motors area branch circuit article 430 is completely different with the other article. Motor has its own rules, and if you had a chance to go to the article 430, there is a picture which it shows everything related to motors, and when you calculate every pieces of the motors as far as the overcurrent device, the branch, the feeders, and everything here has its own rules. Then based on what we talked, we can say branch circuit conductor, but for motors. Then these are related information for motors. We have a single motor, which is continuous duty and draws 70 amp, and the rating of termination is 75 degrees Celsius. Now, if we go to our index in Tom Henry, we're looking for branch circuit, motor branch circuit, article 430.22. Now, if I'm trying to go back to the article 430.22, let me see what can I find. Article 430.22 talks about single motors. Remember, 21 start motor circuit conductor, which is the branch circuit. Now, let's see what it's talking about. Conductor that supply a single motors used in a continuous duty application shall have an ampacity of not less than 125% of the motor full load current rating. Remember, 125% just apply for single motor. If several motors is article 430.24, then we should jump to the other article, but here this is enough for us. Whatever we have as a full load current, we should multiply to 125%. Branch circuit conductor sizing for single motor 430.22. What we should do, two steps. First, you should go with the full load current and multiply to 125%. That is the ampacity. Then you should go to table 310.16 and select the conductor with the required ampacity. If I to do the same, I'm going to the table, required conductor ampacity 70 amp multiplied to 125 is 87.5 amp. But let's see what we have in the table. I did the same, put the question here and go piece by piece to see what we can find. We have a THW wire. Okay. They said it should be copper. We should have a copper, and let me make this blue to match it with the color coding we have here. Copper. Now it says 3-phase continuous duty AC motor that draws 70. Consider all termination is 75 degree. 3 is 3, which is 75 degree. Now what we should do is, we have 87, our calculation is 87.5 amp. We need 87.5 amp wire. Let's see what we can find based on what we did. We are in this area, we come down and let's see what wire is appropriate for this motor. 65 is a small, 85 is a small because R is 87.5. Then the next one is 100. 100 is perfect because it has more than what we need. And if I'm going to the left side to see what gauge wire is, 3 gauge wire is proper for what we're looking. And if I'm go to the question, 3 gauge wire is the answer for us. And if I summarize what we did, just we identified the full load current, which is 70 amp, determine the conductor size based on the full load current, 70 amp, multiply, these are related code section, 70 amp multiply 125%, 87.5 amp. Then we come here step 3, choose the correct temperature rating, 75 degree, we choose that. Refer to NEC table 310.16 for conductor ampacity. We did 8 gauge is 50 amp, 6 gauge is 65 amp, 4 gauge is 85 amp, and 3 gauge is 100 amp. Then 3 gauge is what we're looking because it's more than 87.5. And the conclusion, and if I'm showing you the smart tab I have in my book, is show me, like really help me to like the cheat sheet. All related to the motor calculation is in the top. The 43.22-24 is coverage for branch circuit and feeders. 43.32 motors overload. 43.52 motors branch protection, which is if I'm looking for feeder protection, I'm going straight here. If I'm going for table, all the table are related to the full load, I'm just going here. They give me like the cheat sheet here and help me go fast to the answer. And see you guys in the next question. Question 8. You have determined a conductor has a computed allowable ampacity of 75 amperes. What is the maximum standard amp rating of the overcurrent protection device the NEC permit to protect this circuit where this is not a motor circuit or part of a multi-outlet branch circuit supplying more than one receptacle? A 70 amp, B 75 amp, C 80 amp, D 85 amp. The keyword here, overcurrent protection device for wire or conductor, and this is the main area, but the rest is related to ampacity of 75 amp or something like that, is other related information. But remember, this is not the motors, this is not multi-outlet branch circuit. If I highlight the area what we covered, we have conductor, overcurrent protection, and these are some information related to that. I couldn't find any related information in the Tom Henry's index. You are go and check by yourself, but as I said, if we couldn't find anything in the Tom Henry's index, then we jump to our NEC index. Let me go to conductor side, and in the conductor side we're looking for, from C we should navigate through ABCD to go to the O section to find overcurrent protection device. Then A, B, C, and we just go still C, G, I, L, M, and O, overcurrent protection device. 240.4 is what we're looking. Let's go to 240.4, and 240.4 protection of conductor. This is what we're looking. Conductors other than flexible cords, flexible cables, and fixture wires shall be protected against overcurrent in accordance with their ampacity specified in 310.14 unless otherwise permitted or required in the 240 overcurrent devices rated 800 amp less. The question was talking about 75 amp. Then we are in the correct area. And when we read, they said the next higher standard overcurrent device rating above the ampacity of the conductor being protected shall be permitted to be used. If we have a 75 amp for conductor, if we don't have any overcurrent device for 75, they let us to go to the next side. And let's read the rest. Permitted to be used provided all of the following. We should have these conditions to be able to use that higher rating. 1. The conductor being protected are not part of the branch circuit supplying more than one receptacle for cord and plug connected portable loads. 2. The ampacity of the conductors does not correspond with the standard amp rating of fuse or circuit breaker without overload trip adjustment above its rating, but that shall be permitted to have other trip or rating adjustment. And let's see what CC says. The next higher standard rating selected does not exceed 800 amp. Okay, what we're looking, definitely not exceed 800 amp. Then we can go to the next size. If I go to find this overcurrent protection device side, which is, we should go to the table 240.6.A. These are standard amp rating for fuse and inverse time circuit breaker. 70 amp overcurrent protection device is small for our situation. Then we can go to the next higher amp, which is 80 amp. Then based on the question we have, C is the correct answer, 80 amps. See you guys in the next question. Question 9. A 208 volt 3-phase 50 horsepower squirrel cage continuous duty AC motor has a full load running current rating of A 130 amp, B 143 amps, C 162 amps, D 195 amps. If we try to find any related information as far as the keyword and other related information to keywords, we can say we should definitely go to the motor section to find the full load current and type of the motor, horsepower, voltage, and 3-phase is important part of what we're looking. And if we summarize what we said to the next page, we're looking for full load current, this type of the motor, 3-phase, this voltage. Remember one thing from the EC and M magazine and my old book, which is whenever you're looking for full load current, remember C as a code, you should go to the code book. Either of those tables give you the full load current. If you're looking for a full load amp, that is the nameplate. The motor nameplate is used to size overload protection, but full load current, we just use full load current to size the conductors, short circuit and ground fault protection device. Now in smart tab I have area 430.27 to 250. All tables find full load current for any calculation you want. Now let's go to Tom Henry's index. In the Tom Henry's index we have full load for 1-phase motors, 2-phase and 3-phase, which is what we're looking is 3-phase, and this is the table we should go T.430.250. If I go to NEC index, I go to motor section, and in the motor section when I navigate through I just see it says full load current. See full load current motors. Then I should from the M section, which is motors, jump back to the F section, and I'm jumping to the F section, full current motors, full load current motors, which is 3-phase table 430.250. Now let's go to the table, see what we can find. The same as before, I put the numbers, what the question asks, to match it to the table we have to easily figure out what we're looking. 430.2050 was the index told us to come here. First, let's see here is a full load current 3-phase alternating current motors. Let's match number to each part. 1208 is 208 volts. 2 3-phase AC motor. We have 2 here. 3-phase AC motor. 2 here. 3-phase alternating current motor, which is AC motors. 350 horsepower, we find in the horsepower section 3, and a scroll cage, which is, if you see here, induction type a scroll cage, and wound rotor, which is, we are in the correct area. Now we're looking to find full load current. If we come down from 280, and if from the 50 horsepower we go right side, the intersection is a full load current for this motor, which is B 143 amp. See you guys in the next question. Question 10. What is the maximum distance that a disconnect switch is permitted to be located from the operator's station for a portable carnival ride? A 6 feet, B 10 feet, C 25 feet, D 50 feet. The keyword here could be somehow carnival ride, and when we go to carnival ride, probably any area related to disconnect switch, or we go to disconnect switch to see do we have anything for carnival ride or no. And if we summarize the keywords, we have either of those two could be help us, but I prefer first go with the carnival ride, portable carnival ride, then because disconnect switch should be variety of options. But here maybe we are faster to get to the article we are looking for. When we go to the C, carnivals, circus, fairs and similar events, article 525. Then let's go to 525, see what we have. Just navigate through to find disconnect switch. And let's go just navigate through We see here riders, tents, and carnival. Disconnect means a means to disconnect each portable structure from all ungrounded conductors shall be provided. The disconnecting means shall be located within sight of and within 6 feet of the operator's station. That's what we are looking for. This is the answer we are looking for. The answer is A, 6 feet. See you guys in the next question.